Hello, people. We're back, and I upgraded the camera, meaning I switched the camera from my computer camera to my phone camera because that's just so much better. Also, there's something on my nose. No, I have paint on my nose. I was painting downstairs for something in the residence, and then I guess I got some paint on my nose. Okay, I can get it off easily. That's very nice. Very good to see you once again. My last stream did not go so well, so I'm glad that we maintained 4 minutes of smooth stream, and that's very nice. So let's get to work, brothers. We're going to be working on some mathematic, and let's close these two. Let's close down that. We're going to be working on some derivatives. So let's start the Pomodoro timer and get to work. So what we're going to do is we're going to use a combination of my math tool over here and then also do some of my actual homework for you today. So it looks like we're jumping a bit forward in the lessons of the day. So I'm just gonna don't put the link for this stream here. But I'm glad to be back. Um, for this question, it's gonna be a bit different because the question in hand we're trying to find t and not find the actual thing, and we have a derivative kind of. But so this is an interesting question, and I don't know how to do it. So we're going to have to consult different resources to figure it out. So first of all, we're going to consult my textbook. And this, I think, would fit, since this is week 2, it would fit into either the fundamental or the, so it's either 4.8 so yeah, I think it's going to be in this one. So the fundamental theorem of calculus, but for, fundamental theorem of calculus, so you can get the thing. And based on the Isaac Newton brother. Let's open this bit.ly link for no reason. Yo, it gives us answers and on who Isaac Newton is. Very nice, very nice. Okay, let's switch back over to the preview so that we can keep looking at my textbook. So, what are we looking for? We're looking for something about B. We're looking for something about B, for real. So, it can be very difficult to we can now have a powerful using antiderivatives, something that we did last week. But we need to find out how to find this x though. So we're going to find find dx dy if yes. So this one is they're using antiderivatives to solve it, I think. Right? Because you have dy dx. The derivative of this would give you this. No, because you're removing the derivative, and then you just have x plus that. So then the answer would be negative 3x. So then y is I'm confused. So what are we looking for? I don't know. I'll figure out in a sec. Let's look over to the question at hand. I don't know, because we're trying to figure out. There's a question here that will help us out. Because this is 5.5. We're checking 5.4 questions. And 5.4 questions are not the ones that we're looking for, because we're looking for the x, the t for the things, but then this textbook does not help me to do that. So what we're going to do, I should have done this earlier, but I was doing work, so I couldn't do that. So let's skip this question and move on. Let's just keep going. Find the derivative of that. No, you can't do that. I think I can do this one, but I don't want to. This one definitely we can do, because we did this, basically all of this constantly yesterday. So we can find the indefinite integral of this question here. So let's go and do it. And that's just the way you have to do it sometimes. So you just have to just struggle through something that you can't do, do things that you can do, and then you get to the things that you can't do earlier. And I wish I did that during my tutorial, but who cares? I should have asked, but that's just the way that things are, you know. Sin 8 sin x. So let's go and make an equation. So then we're going to say equals. Should we do the whole thing? Yeah, let's do the whole thing. So int no slash int Oh no, so you don't need to do it. So just go 8 sin x sine. Oh. There we go. 8 sine x plus 9 cos x dx equals 2 minus, no, it'll be 8 cos x plus minus 9 cos minus sine x. That's the antiderivative, whatever. So sine x would it be negative? Wait, let's check this. I keep forgetting what the antiderivatives are. Let's just check one more time. So the cos is, for sine, it's negative cos. Okay, so for sine, it's negative cos. And then for this, it's positive sine. So then it's that, okay. What? Let's see. Let's go. Easy peasy. Now next one, we'll do the same thing, but for 3 simpler ones. Okay, so we're going to do I'm not tired. But like the thing is, I think math is an interesting subject. I don't entirely love it. No, I do love it. It's just it's an interesting subject. What I think we'll do for this first one is to figure it out soon. I think for the first 1 and 2, I think what I can do is I can substitute you, I think, in, and then you can get the answer out quickly, but I don't know how to do that yet. I'll hear myself tomorrow, I assume. And this one, oh yeah, this one's annoying. Because I remember that I've done this before. I haven't done it specifically, but I looked at it. I looked at it when I was doing the studying for this one. So when you go over to the thing here, so go to fundamental. Yeah. So for A, you have XA, so then you can, so you, That could help us here. Okay, so we have our 1 over here. So t, x, whatever. So if we have the word, let's get over and open this one. So then if we have the x here, so we're using the fundamental theorem. Let's just check what is the thing that they use for it. So for this one, they put this, and because x is the thing, so they just substitute x in and then do the derivative to find dy dx. But we're looking for t. So since we're looking for t, it's different. But so dx of the thing is dy. So then what if we do that? Wait. Okay, so if we just do the derivative of this, we can get the answer of this. Yeah, because we'll have the actual function, and then we can just put the thing in and then solve for t. Right? I'm pretty sure you can do that. Yeah. So for this one, so in this one, I can just go. So for this, I need to do the derivative of this to find what this is. Okay, so, okay. We're figuring this out. We're figuring it out. We're figuring it out. Because, what is this? So it's just doing derivatives. And then this is, what was the second? What's next in the actual, what's in this one? What does it say? Yeah, it just tells me to do the same thing. So I'm like, who cares? Eek. Okay, interesting. Okay, let's just do the thing that we set out to do, which is solve for this monstrosity. So if we have, let's undo that and then go dx dy equals to, so control E equals dx over dy equals to dx dy or the other one. Let's look up. Yeah. So it's dx dy. Of the whole thing? Oh no, so just dx. Okay. Derivative. Close my Notion, right? And we're already running out of time, but we got some progress, you know. So dx, d over dx or whatever. I don't remember how. Yeah, d over dx. And then go slash and 0. Then multiply t, and then it's just x squared plus 10x divided by 24. No, plus 24 divided by 1 plus cos squared x. Does it just cancel out that dx? I don't know. No, it does not. So we would just cancel it out, and then you have it just cancels out, and then you have the minus 3x, I'm assuming. Yeah, so minus 3x. So then it's just so then you do the derivative and find x when it's at when find t at 0. No way. Because now if I do this, it will now be dx dy equals to x squared x squared plus 10x plus 24 divided by 1 plus cos x. And then, so that's just how it is. And then you now have it like that, and then you can solve for, you can't solve for anything. We just have the derivative now. So then the local max of ft is, local max is when derivative is 0. So, okay, that works. So we can just put 0 in here, obviously. Okay. This thing's about to rain in my ear. In all of our ears, bro. 7 minutes. Okay, 7 minutes. We still have time. I close this notion, bro. Also, just move this over here so it's just much easier. 0 equals that, and then you can. Yo, this is actually super easy. Barely any inconvenience. Reference. 0 equals to 10x. No, x squared. Plus 10x plus 24 and then solve that, go x, so then 24, so you have 12 and 2, so then that works. 12 and 2, that work. 12 minus 2. Yeah. Because it has to be positive 12. So do we have to do so the thing 6 and 4, 6 plus 4, yeah, that works for me. So then x equals 6 equals 4. Those are the zeros. Let's ask ChatGPT because I've done as much as I could. I don't know how much more I can do. So let me just ask. Let's see what it says. Let's just ask our good friend ChatGPT. No attention. I'm trying to do it with as little ChatGPT as possible, but like it looks like it's not letting me do that. But we're learning. We tried a lot. But because that's just a single function, I don't think it'll be. So let's see what it says. So distract the function, derivative set, yep, so yeah. Interesting. But can you just do 6 plus 4? X equals 6 or 4, huh? We're all confused here. We wish that we had people that could teach us things, but getting, but like I don't think you need to use them. Quadratic formula. So 6 plus 4 equals a thing, 6 plus 4 equals that. So then it just goes x plus 4. Oh yeah, it is a negative 4, negative 6. It's true. That's confusing. I don't know what to do. I don't know what to do. Because this is not, this is acting as if it's a single value. The question says, my question says, okay. So why should T? Yeah, because T has to be bigger. Yes, because it has to be bigger than the thing. So okay. So if okay, so this gives you critical points that you don't. Okay, that makes sense. So let's see. But it's not right. It's not 6. It's not 6. Because it's definitely negative 4 and 6. But what are we looking for? I don't want to hear the sound. So we're cooked, guys. We're cooked. We don't know what to do. So I'm going to leave that alone and ask that as a question to someone else. You know what I mean? This one I need to use fundamental formula. This actually makes sense. This one actually makes sense. Like I can actually just use the theorem for it. But this one I don't know what it is. Like it just doesn't make sense to me. Let's just throw it into a random. Let's throw it into perplexity. There we go. Let's use the more complicated one. And then they can even give me like a video too. Oh yeah, this thing access for PDFs. Let's put negative 6 and 2. Okay, so we just had to put negative 6. That makes sense. Okay, so I should have done that the first time, but I just didn't. Interesting. So it was right the first time, but it was just like, no, 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 no. Okay, good to know, good to know. So let's check. So what we found is that I did what you need to do. So you just derivative and then get the thing. So you have the derivative of that. So then you solve for the thing, find that, boom, go back over here, solve for the points, check which one's the 0 by doing the second derivative or whatever, and then go back, put it in. So then the second one, this one here, what we'll need to do is basically the same thing, but we're going to use something. I don't know. So we have that done. Very nice, very nice. But hello, people. Thank you, chatters. No chatters, but welcome people that are joining me live. I'm very grateful for you. It is 10:54. Oh no, my thing has been showing the wrong person. It's been showing me off to the side here, but now it's fixed. Very interesting there. But now we are back to normal. I'm very glad. Yay, yay, yay to me. Thank you people for watching. We're now within 2 minutes of our break being over, and we'll get back to work. But right now we're just looking at all the different questions and seeing which ones I know how to do. This one I know how to do. I just had to do the integral. I just do the thing, and then you just plug the numbers in. This one you do the same, I guess. Yeah, but you have to use definite figure. Okay, so that's what you have. So whenever you have ever x or something, you have to do definite. I'm assuming. Because let's look at the. I think what we're for this next Pomodoro section, we're just gonna look at the textbook and figure out what this fundamental theorem thing is doing. We'll just mess around with the examples for a bit. We'll figure out that. I think we've figured out this first one, which is just the dx thing. So these two are easy. They just do the dx, and then you get the x minus whatever, and the x down whatever. And then for this one, you now have to change it and just be like, whoa, what's going on here? So you have to substitute for u, and then use the chain rule to chain rule it out, I guess. Because you have the u, and then the u transfers to u equals to that. So then, so dx equals to, oh, interesting. So you use the thing, and then you keep it like that, and then you, wow, that's interesting. So in this case, what you do is you have 1 plus 3x squared, then you have that, so then it will now be dx that, let me bring the dx that one out. Okay, ready people, let's begin. So we're just gonna keep studying this thing, and then we'll go back to solving our questions for it. So we've done this one already. So now what I'm trying to do, we're going to, what I've just discovered here is that when you have the upper limit is not x, but x squared, we have to do a substitution, and we have now, it now makes a composition out of the questions. Because now the interesting thing is like when you have because when you're doing a definite thing, you have to do the different things. But what we are just trying to do right now is just trying to calculate the derivative of these weird integrals, right? So to put that in, you have to put this substitution. So you make the x squared u. So from up here, the x squared u. Yep. So let me full screen this. X squared u, and then you make the negative 3x. Yeah, so then you make this, you make this u, and then you apply that across. I don't know if this is this working? I don't know. I don't know if you can see how much of that you can see. Let's I'm gonna just go with this. I think I'll just do it from here because it's not easier for you to see. So, and I'll move it to this side since the camera blocks that side a little bit. Yeah, there you go. So when you have so you apply the train rule because you keep the thing because now the derivative of this would now be the derivative of the original function, and then the derivative of this. So then, but because you have the integral here already, it just brings down to the cos u, so you don't actually do the derivative of this because this is the one that's blocking that. So you go cos u that, and then because you have the u, you just bring the u in, so then that'll be x squared. So then you have 2x, so then you have 2x cos x squared. Because on the other one, you just brought the x, instead of putting the t here, you bring the x and bring it there. But for the interesting thing is that you have to flip it that way. Interesting. Because that's the only thing that this one's changing. This one's changing that you have to flip and you have to put the negative because of that kind of thing. Okay, that makes sense. For this next one, you have the same kind of thing where you flip first because you want the one on the top because that's what you need to have you need to have the weird thing on the top. So this one has to be on the top. So you flip it. So then you have negative. Then you keep the dx. Remove the negative out. Keep that. Then you make the thing so you have the thing substituted in, boom, then you have the dx thing here, and then you do the derivative, so that gives you, bring the 2 out, do the 6x, and you just multiply on top, and then you got that out. Interesting. So now let's go on to part 2 and see if there's anything else that we need to check. FBX, I think this doesn't feel like there's anything wrong with it, I don't think. Yeah, this one's just that. So then this one is just, yeah, makes sense. This one's just showing you how to do the derivatives now. Like the integrals way, like when you actually have to solve for them. But for the other one, you just have to do the thing. Also, this camera looks so clean. I don't know why I keep using the other one. It's just a hassle. It's not that much of a hassle, but it's just like not as easy. So you just do that, boom, 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 and then it will just work out the way that you need it to. Understandable. Okay, so let's go to our questions again and continue the struggle. So for this one, we would need to this is 5x over x whatever. So then this is x plus 1. Okay, they're trying to trick me because this is it just seems like it's something, but it's nothing. What it actually is just, look at it. It's right there staring me in the eye. Right here. It's arctan. It's arctan looking at me. It's confusing because the 1 is not in the right spot. So then this is 5, 1 over arctan or whatever. Yeah. 5 times 1 over, 5 times arctan. So 5 arctan minus, 5 arctan 1 minus 1. Wait, yeah, minus, yeah. So you start this one and then you do the second one after, right? I'm pretty sure that's the way that this works. You go this first one, b minus a, right? So then this would be minus, so we'd add to plus. So that works. For this one, we just do, that one's just simple. That one's just a easy antiderivative thing. This one is I think this also could be an antiderivative thing, could it? because now this has an x squared under it, so I'll have to check. And this one, you see, fully antiderivative. This one also simple antiderivative. So this is the only one that I need to actually check. So we have the setup here. So let's grab the thing. I think I already have this one, don't I? No, I do not. Okay. So let's go to question. Should we do question 2 first? Yeah, let's do question 2 first. We'll figure it out in a sec. Okay, so this is question 2, and okay, that simplifies it. So, okay, so find the derivative of this, where you have u2, is that, and then the other one is u2 plus whatever. So we're finding the derivative of the function, so dx, gx, or whatever, dx or whatever. I'm spitballing. I'm saying whatever too much. Or whatever. dx, dy, d/dy of the thing equals 2 slash int overhead. This is derived by 8x. X, and then no, we'll put 0 on the bottom so that we just skip this step of the other, because we already have the hint. So like we'll just do the status quo. U plus 2 divided by u squared because it's not x, so we'll have to actually multiply by the dx. So then that'll be the. So this is not that hard, but it's just you have to just do the thing, right? Nope. So then that will now be du, and then you have to now multiply that all by 8, and then this would be minus the 4 slash int, and then you have 0 times 4x, and then you go u plus. So then because it's just, separating the thing, so we'll just go do dx, and then you just do the same thing on this one. U plus 2 divided by u squared plus 2, and then times 4, and no, hit the du, bro, hit the du, and then that will now give you out command E, no, control W, so now we know, so that'll be 8 u plus 16 minus 4 4 for u it would be 4, yeah, so you put the x in. That would be 8x plus 16, and then for x plus 8 minus 8, yeah. And 8x plus 16. Then you have u squared. So then that's now 8x squared plus 2 equals to dx dy. So that's what it equals to. So then you now subtract, so then that'll be 4x minus 8 plus 8. X was 8. X was 8. Let's just go and check the answer real quick, because I think that's the answer, but like, we have ChatGPT for a reason, man. We have ChatGPT for a reason. I've already done all the work. It's not like I'm doing it afterwards. So then you do the thing, so 4, so then you apply it to it, and you get that. So you have to wait. What? Oh yeah, because you have the 4x. Yeah, right. So then this will be 8. Oh, okay. So it just goes 8x. Okay, that makes sense to me. So I was wrong. So what I need to do, so what I have here is wrong in the sense because I didn't multiply the 8 part. So this would be 8x. Okay, so let's separate again. Opened my soap and now it's stuck in my eyes, bro. Why did I do that? Why did I do that, bro? That hurts the eyes, bro. That hurts. That hurts uniquely. So then it's 4. Then you have 4x squared plus 2. So then you go one more. Mm-hmm. 64 times 64x, not 64x plus 16 minus 16x plus 8 divided by 4x squared plus 2. Okay, so then we have that set up, and now we can go over here and type that in. But I don't like typing it in. It's the most annoying part of whiteboard, is that like you have to do it, type the whole thing out, and that's annoying. And I was kind of right. I completely forgot that I had to add the add x as well, but I was almost there. I almost got it. You know. And also, this is supposed to be -6, and this one is supposed to be -4, because that's just how that works. But I didn't know how to do my factoring correctly. I just factored. Yeah, I factored correctly, but wrongly at the same time, because it's supposed to be x plus 6, x plus 4, and then you now do the thing, and then you have the negatives because you move it out of the bracket. But shame on me, I guess. But let's get to work. Why does this thing take priority? I don't know why. Okay, so we'll take that, boom, and then we'll just bring it down here. There we go. So it'll be 64 x plus 16 divided by 8x squared plus 2 minus 16x plus 8 divided by 4x squared plus 2. Should be right. And it's wrong. Why is it wrong? Oh, yeah, because you have to square it. So then this is 16 squared. And then this one is 64 squared. Good try. Let's go. Okay, so one thing that we need to figure out, something that we need to continue to track is when you have the UX. So this one, I should put it in the brackets here so that you can track that. I wish I could remove the brackets afterwards, but I can't. So this will now be 64, so let's correct that as well. 64, and then this one's 16. So, for future reference, whenever we're doing that kind of thing, we just examine it that way. And so now we're done with that. I don't think I'm going to be able to finish another question before the end of this time up. Or I can do one of these quick ones and then have it done that way. Or I can finish this one and then just call it a day from there. I think that's what I'll do. Grab this and let's go. Let's just check the thing again. No, stop showing up, you notion nonsense. So let's go back over here. 5.4, the fundamental theorem. So you got x squared, so x squared, da, da, da. So then what we're going to do is we're going to have the one up, so move that one up. Does the 1 matter at all? No. You'll leave the 1 doesn't matter. Okay, that works for me. So if the 1 doesn't matter, we're going to just do it the way that it is said. So bring out the... We're going to just finish this one even if when the time runs out. Because I want to have less of this actually have to be done, you know? What is this? Okay. Okay. Control E. So then, if we go, so now we have x squared, and so we can use that as u, and then we have it the dt whatever. So do the chain rule twice. Ugh, that's annoying. I don't like that. I don't like that at all. Or will we do chain rule twice? No, just do it once. It looks like we won't, but we will, but we won't, because things are just generous sometimes. And I have no water. I have no water. That's just sad. I'd like a little sliver of water. So let's just do it. What's the schedule to do? I don't even. We'll check that after the stream. But this has been an interesting stream. Not gonna lie. 3 people joined, but there's only 1 person watching at the moment. I don't know who that is, but I appreciate you. I will continue to appreciate you. When we become 100 million, I will continue to appreciate you. 100 million would be crazy. That would be like, I would have to live for like several thousands of years. Maybe another like 40 years, maybe. No, not 40. Maybe 80. 80 years for that to happen. Because like the amount of people that you need online doing calculus. Oh no, it won't be calculus, of course, but like whatever I'm doing then would be insane to have like 100 million people just being in one spot. Because like the highest ones are like 1 million. 100 million would be crazy. To get 100 million to be on like a live stream of internet capacity, of course, but it'd be something, which could happen, but it just hasn't, you know. Then, but that's not what we're looking for. We're looking for dx, dy dx. Let's go to plus. Let's go. Pause it for me, please. We don't care about the time. We will just finish this once and for all, and then we'll be done. So let's put a dx, d over dx here, and then put a u over here, u, and then put a 1 over 5. And then do you put a u there? Let's just check. Yeah, you put a u right here. No, you don't put the u yet, so just leave it. Just leave the thing as it is. I love stream beats so much. Just so magical. I love it. And then not plus, so then it'll be times the dux. So then it will now be y over dx equals to 1 over 5 x squared minus 1 times 2x and then that's it, and then you just have that answer. So that'll be your answer. But oh no. But for now, that's it. Let's just check this last thing. Let's check it with ChatGPT real quick. But I have my answer already. But it could be wrong, so like, because we were wrong with the last one. Yep, I was right. Let's go. X4. Oh yeah, because you just do the squared. You do the squared thing. Because this is a t squared, not just t. Yeah. Right? Yeah, so you go t squared squared. I already put t here, so I'm gonna just put this squared that. That's something that I need to keep track of. Like, that's something that will be tracking next stream, especially for just cracking those little things. Why is it not completed? X dx dy equals to 1 over 5 x is 4 minus 1 13, and then you have 2x, and then that'll be it. Okay, people, I think that will be all for today. I hope you enjoyed the stream. It was fun. I wanted to see if I could glitch out the thing, but it was fun. I hope the sound quality was on par, like it was transferring correctly, because my video is off, so I don't know if it's the latency is now back to sync because the other one wasn't synced, and I don't know if that was caused a problem and made this show unwatchable. But it was great being with you guys. I will see you in the next stream while we talk about linear algebra, and I will complete the rest of the things by myself before the end of the week, and we'll be done. Very nice. See ya.